Hi folks, one of the very common types of systems of equations questions is one that involves solutions and mixtures. Okay, so this is one such example. So let's take a look at what's going on. We have vinegar as a solution, and we have this lab that's got two strengths of this white vinegar. So a 5% solution and a 10% solution. That means 5% of it is acetic acid and the rest is water. This one here, 10% is acetic acid. Okay, and they want us to figure out how many milliliters of each of these solutions you need to produce 50 milliliters of a new solution, one that has 9% vinegar. Okay, so let's see how we can start that. So again, look at the question and you get a sense as to what our variables should be. It should be how much, it should be the amount of each solution. So here I'm going to say let X be the amount, the number of milliliters of 5% solution, and then Y will be the number of milliliters of the 10% solution. Okay, so here we have our variables. Okay, and let's look at the information they tell us about what we're trying to produce. They tell us that we're trying to produce 50 milliliters of this solution, and it has to have a strength of 9%. Okay, so that's two pieces of information. The first piece of information tells us about how much we have to produce. So this is going to be the total. So how do I get the total? Well, I'm going to take the amount of the first solution and add it to the amount used from the second solution. So there's my first equation. The amount of the 5% solution plus the amount of the 10% solution, if I add those together, should give me the total amount that I'm going to be producing. 50 milliliters. Okay, so there we have one equation. So let's look for a second equation here. The second equation is going to come not from the amount, it's going to come from the strength of the solution. I need the final strength to be 9%. So that means I need this solution to have 9% acetic acid. So what we're going to do is we're going to figure out, well, how much acetic acid is in that first solution? Just that, not the whole thing, not the acid and the water, just how much acetic acid is in that first solution. Well, it's 5% acetic acid. So how do I calculate 5% of something? I multiply it by 0.05. So I'm going to have 5% of my first solution, which is X. This represents how much acid is in it. Then I'm going to add to that the amount of acid in the second solution. And I calculate that as 10%. So that's going to be 0.1, which is 10%, times the amount of the second solution. Okay, so just to recap, this expression represents just how much acid is in that first solution, and this is how much acid is going to be in the second solution. And if I add them together, I should get the amount of acid in the final vinegar solution. Okay, and how do I calculate that? Well, I know that the final one has to have a strength of 9%. So it's got to be 9%, 0.09, times the amount that I have in the end result, which is 50 milliliters. Okay, so I had to do a little bit of calculation here. Okay, so now, lo and behold, I've got an equation of a system of two equations and two unknowns. Okay, so again, here I could use a substitution, but I'm going to use elimination. So what I'm going to do is multiplying things by 0.1 is pretty easy. So I'm going to multiply equation 1 by 0.1 so I get the same y coefficient. So let's see equation 1 multiplied by 0.1. Okay, and what do we get? Well, we get 0.1x, okay, plus 0.1y, okay, equals 0.1 times 50, well, that's just 10% of 50, so that's just going to be 5. And then my second equation doesn't change. I'm going to have 0.05x plus 0.1y equals, and let's just calculate 0.09 of 50. Well, if we kind of do it in our heads, let's see. If this was 100, 0.09 of 100 would just be 9, so presumably this would be half of that, so 4.5. Let's see if that's indeed correct. Okay. So what do we have? 0.09 times 50 is equal to 4.5, as we suspected. Okay. Now, I would certainly encourage you on a test to always use your calculator. Okay. So here we have the point ones have the same sign. So we're going to subtract the two equations. Remember, if they have opposite signs, we add. So here we have 0.1 times 0.05. So that's just going to be 0.05x. 0.1 minus 0.1 is 0. And here we're going to have 5 minus 4.5 is just going to be 0.5. Okay, and so x is just 0.5 divided by 0.5. Okay, we definitely should be able to do that in our heads, but I'll just use a calculator just to be sure. 0.5 divided by 0.05 is equal to 10. Okay, so there's our x value, and now we're going to use one of these equations to find the y value, and I don't think it'll be too surprising that I'm going to use equation 1. Okay, so we have x, which is 10, plus y equals 50, so y is equal to 50 minus 10, which is 40. Okay, so let's answer the question, and the question was how many milliliters of each do we have to use? Okay, and since everything was already assumed to be in milliliters, I don't have to worry about the doing any kind of changes. So had they asked me, say the question was in liters, maybe I'd have had to make a little change. So here we need 10 milliliters of the 5% solution and 40 milliliters of the 10% solution. Okay, so there we have it. There's our answer. Quick recap. Number 1, always define your variables first, given right in the question. Number 2, realize that you have the two pieces of information that allow you to create an equation here. Piece number 1 was about the amount of each solution that you're using, and the second equation was just about how much acid was in all the solutions, and that's where we had to use the percentages. Okay, that's it for this one.